So that product for game dev is all about directions, basically. So I will show you first how we calculate a dot product, and then I'll show you some examples in a game engine. So let me start by drawing a vector here. In fact, I'll draw two of them. So let's say that's a 45-ish degree angle. So I'll just write that here, and then this vector is 1, 0, and it's going to be 0.7 and 0.7. So, two ways to calculate a dot product. One is to simply sum up all the units of the vectors. So let's say this is vector A and this is vector B. So it would be AX times BX plus AY BY. And if we were doing 3 dimensions, then it would also be the Z dimension as well, which we don't have to worry about here right now. So if we do A dot B in this case, that would be equal to AX, which is 1 times BX, 0.7, plus AY, which is 0 times 0.7, which is the BY, so 0.7. So that comes out to 0.7 plus this is just 0, and that is 0.7. And the other way to calculate this is using the magnitudes of vectors. And since these are unit vectors, they have a magnitude of 1. So if I write magnitude A times magnitude B times cosine of alpha, let's say that's the angle here. And if these are unit vectors, that's just 1 times 1 times cosine of 45 degrees, which leaves us with 0.7 or something like that, close to the number. So why is this important and how can we use this in game dev? Let me just draw a few more vectors and then I'll get to that point. So let's say we have vectors in all these directions, and I'm not gonna calculate all of them separately, but I will do like a cheat sheet here. So let's say when we have two vectors pointing the same direction, the dot product is gonna be 1. If they are facing the opposite directions, it's going to be -1, and all of these that are at right angles are gonna be 0. So how can we use this in a game? Let's jump to the game engine and I'll show you that. So here we are in Godot engine, and there is well, a representation of a vector. Actually it's two vectors, you just can't see it well. If I offset them a little bit, then you can see there's a blue and a red one. So the console log here is logging the dot product, and the way I do it is simply do a dot method on the vectors. If you use a different engine, most likely there is a method on vectors which can calculate the dot product for you. So that's what that's doing, and we see now if I start offsetting these vectors, they will drop off down towards 0 at a 90-degree angle. So 90 degrees is 0, and then if I go back into the other direction, then again we get close to 0 and a 0 at 90 degrees as well. If you cross the threshold, then it gets a minus symbol, and if they are facing the opposite direction, then we get a -1. And of course it doesn't matter, we can go up and down as well. 90 degree up is also gonna go towards 0, and anything beyond that is gonna be with a minus sign. So yeah, you can basically see that as long as we are facing somewhat in the correct direction, it's a plus sign, and if we go on the other direction, then it gets a negative symbol. So let's jump to the other example to see what we can build with this knowledge. So here's the second example. We have a box here that changes its glow basically once I look straight into it or if I look away from it. So how does that work? So we take a dot product between the vector from our position to the box and the vector that our camera is facing, and once they are aligned, we do some operations on the box. So I'm just gonna draw this out to make it make sense. So there's the box, and here is our player, and let's say our player is facing this direction. So we have to take a vector from us to the box, and then a vector from wherever we are facing, do dot products, and then do something with that number. So once that the vectors are aligned, you remember they're gonna go close to 0, or I mean close to 1, and once they're aligned, it's gonna be exactly 1, and then we can do some operation with that. If I show the code, so this is just a method that I wrote on my player. So basically we are just constructing the two vectors that I mentioned, and remember they have to be unit vectors, so we just always want to have unit vectors here. and then we just do a dot product in them. And then our box here calls that function, and it checks if the dot product is within a certain threshold. We set a glow on that box. So that's what's happening here. It works really nice, as you can see. And if I just make a few of these boxes, then we can see the effect even better. So now we can look at each box and it glows up the way it should. And we can even do some other operations on it. For example, if I press my mouse, we can delete the certain box that I am looking at. So that's one more example, and let's jump to the last one. So this is the final example. We have this scary looking guy chasing us, but I want to do something different. I want to make it so that he can only chase us if we are not looking at him. So how can we do that? Well, basically, again, we can do dot products and see if we are looking into the enemy. And if we are not, only then give him permission to chase us. So what I mean by that, so we have an enemy and we have our player. And we can say if we are looking directly at the enemy, then our dot product is going to be 1. And then if we are looking at a 90-degree angle from it, or anything beyond that, it's gonna be with a negative sign, right? So from 0 all the way to -1 and back to 0. So if I simply call that function that I showed you before, we get a dot product, and we say if it's less than 0, so we are looking at a 90-degree or more from the enemy, then we can give permission to the enemy to chase us. And if we check this out again, you can see he's just chilling there, not doing anything. But if I look away and look back, he starts getting closer and closer and closer and closer. So that's that's a fun way to use dot product as well. And I hope this makes it a bit more clear what a dot product is and how you can use it in your game. So good luck with that.